Okay, we're going to look at today how we're doing a few of our difficult Royals math problems. So first of all, our first problem is a time duration problem, and there's two parts to it. Now, this is based on an anonymous teacher that I won't tell you her name, but the game started at 7:07, and it went all the way till 12:28 a.m. Now, then this particular teacher got home at 2:15 a.m. and had to get up at 6:30 a.m. So we need to figure that out. Anytime we have a time duration problem, the best way to start that is with a timeline. Okay? So if we start the 7:07 to 12:28 with the timeline, we draw a long line, we start at 7:07, we make this one 12:28. Now, in between that, we put all of the complete hours. So we have 8 and 9 and 10 and 11 and 12. 8 and 9 and 10 and 11 and 12. Now, the next thing I want to do is count up how many total hours, complete hours I have. 1, 2, 3, 4. So that's 4 complete hours. But I have these extra little minute spaces on the end that are not complete hours, and I got to figure that one out. I'll start here with the 12 to 12:28, because that's easy peasy, because that's 28 minutes. We don't have to do any extra math for that. But if I look over here at the 7:07, I have to figure out how much time is from 7:07 to 8 o'clock. The easiest way to do that is to take 60 minus 7 is 53. So that means there's 53 minutes over here. So I now know that there's 4 hours, and I have to figure out how many minutes on each side. So if I do 53 plus 28, I would end up with 81 minutes. Now, you would look at me awful silly if I said it was 4 hours and 81 minutes, because 81 is more than 60, and so it's more than 1 hour, so I have to take 81 minus 60 gives me 21. Now that means that I now have 4 hours plus the 1 that I took away, which makes that 5 hours, and then 21 minutes. 5 hours and 21 minutes is how long the game took. Now, that's only the first part of this problem, though. The next part of this problem is to figure out how long the game lasted, or how long this teacher got to sleep. 2:15 to 6:30. 2:15 to 6:30. Put in the complete hours in between. We have 3, 4, 5, and 6. 3, 4, 5, and 6. From 2:15 to 3, I don't have to do a lot of math for that one, because I can use just my knowledge of time to know that would be 45 minutes there. 6 to 6:30 is 30. If I add up my complete hours, I have 1, 2, 3 hours. Plus 45 and 30 is 5, 75. 75 minus 60 is 15. So that means it's going to be 1, 2, 3, 4 hours plus another hour, or 1, 2, 3 plus another hour is 4 hours, and 15 15 minutes. So, the moral of this story is this particular teacher spent more time watching baseball than they did sleeping last night.
That's crazy. Wow. That's for only 4 hours.
The second Royals problem of the afternoon is that the Royals played 14 innings yesterday. In each of the first 13 innings, the Mets got 3 outs and the Royals got 3 outs, meaning there were 6 outs in every inning. In the 14th inning, though, things changed a little bit. The Mets got 3 outs, but then the Royals only got 1 out, which meant the 14th inning only had 4 outs. How many total outs were there? So there were 14 innings. 13 of them had 6 outs, and 1 of them had 4 outs.
Oh, I get it, Phil.
Now, lots of ways that you could use to solve this problem. You could use repeated addition and do 6 13 times and then add 4. Or you could do it as a multiplication problem, which is how I'm going to do it. So I could do 13 6 times, figure out what that is. 6 times 3 is 18, 8 carry the 1, 6 times 1 is 6, plus 1 more is 78. And then we have to add on to that the 4 inning, or the 4 outs from the last inning, which makes that a total of 82 innings. Or I'm sorry, 82 outs.
In the whole game.
In the whole game.
Gwen.
The third problem that we did today was that there were approximately 40,000 people at the game last night. And I heard on the radio coming to school today that the average amount spent by each individual there on tickets, concessions, and parking was around $600. Now, how do we figure this out? Now, we could add 40,600 times. That would be really big. We could do an array and do 40,000 dots in 600 rows and then count those up. That's the way Janae wanted to do it. But instead, we're going to use our knowledge of large numbers to do a multiplication problem, and we're going to use our knowledge of large numbers to make it a slightly easier one. And this is an important skill to have because in real life, we actually end up doing more math with large numbers like this than we often do with small numbers. So we're going to take 40,000 times 600. But we're going to do a little bit of math magic on this. Because we're able to do some number changing on this if we kind of well, we'll just do it normal and then we'll look at how that could be changed. So 0 times 0, 0. 0 times 0, 0. 0 times 0, 0. 0 times 0, 0. 0 times 0, 0 times 4, 0. Did that really accomplish us very much?
Kind of.
Not a lot, except we'll see what it does at the end, which is important, which I think is what Joseph's kind of was. I'm going to do the next 0, 0, 0. But, of course, on the second, you start over 1. So 0 times 0 is 0. 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 And 0 times 4 is 0. I still don't have a lot of actual value in there, but we have done a couple things that were really important. The last one is now 40,000 times 6. Now I'm ready to do the multiplying by the 6. 6 times 0 is 0. 6 times 0 is 0. Make sure you noticed that I started now in the third column because I'm in the third column here. 6 times 0 is 0. 6 times 0 is 0. And it looks like I'm going to run out of room here, but we'll make it work. 6 times 4 is 24. So I'm going to write that. Hopefully you have a neater paper than this. Now if I add that, I have to be careful though when I write this. So I'm going to write it over here, but I'm going to be very careful. 24, but then I have to put the right number of zeros. I have to put 1, 2, 3, 4, 5, 6 zeros after that number. If I put my commas in there, that tells me that there was $24 million spent at the stadium yesterday. Now, now, I'm going to show you something over here that might make that slightly easier to So, when we do 40,000 times 600, since we have so many zeros on the end, we could take these off and put them back on at the end.
Oh, yeah.
And then just do that 6. 6 times 0 is 6. Or I'm sorry.
0.
Thank you.
0.
6 times 0 is 0. 6 times 0 is 0. And 6 times 4 is 24. Now, I need to add the zeros that I took off from right here. Okay? And I added 4, I took out and did not include those 4 zeros. And that would be another way to get that same answer with slightly less math. This next problem relates to Alex Gordon's home run in the 9th that tied up the game and allowed it to go to extra innings.
Yay.
That home run went 458 feet.
Yes.
But how many inches did it go? Well, every foot has 12 inches. Every foot has 12 inches. So, there's a couple different ways that we could figure this out. We could do 458 12 times, or 12 458 times, or we could use multiplication. 458 times 12. Now, double-digit addition like that, or multiplication, can get confusing. So I'm going to change that to 2 different problems. I'm going to change it to 458 times 10 and 458 times 2. 458 times 10, I'm not even going to go through the trouble of doing column multiplication on it because I know that any number in the planet that I times by 10, I simply add a 0 onto the end. So that would be 4,580. Now I'm going to figure out what 458 times 2 is. 8 times 2 is 16. 6, carry the 1. 2 times 5 is 10. With 1 more is 11, carry the 1. 2 times 4 is 8, with 1 more is 916. So now I need to add that over here to this one. 6, 9, 5,496 inches. 5,496 inches. It would be a little more impressive if he said, not that 458 feet isn't impressive, but to say, I hit a 5,496 inch home run. That would be very, very impressive.
Yeah.
As I walked around today, I looked at and saw lots and lots and lots of right answers. I saw some wrong answers, but I saw good thinking even in those wrong answers. I want you to take these home tonight, and if you would like, you could challenge your parents to answer these same questions. And you
My dad's probably gonna beat me.